Okay, good morning. Welcome to our graphical analysis of motion lecture. So last time we discussed about motion, speed, velocity, acceleration. This time we are going to discuss how to represent a specific motion in a form of graphs. And we're going to analyze graphs to know what is going on with the motion of an object. Okay, like for example, a student walks from home towards school with the following data below. So at 0 hour, it's at 0 position. At, at 2 hours, it is already at 1 kilometer position, meaning it has already walked 1 kilometer. After 2 hours, it has already walked 2 kilometers. And after another 2 hours, it has walked 3 kilometers. And after another 2 hours, it has walked another kilometer. And on the 10th hour, it has walked a total of 5 kilometers. So let us represent this one in a graph. So in a graph, in your Cartesian plane, so we have here the x and y axis. So the x-axis will be the time in terms of hour, and the y-axis will be the position in terms of kilometers. So our graph should look like this. So we have the y-axis as the position in terms of kilometers. So this is 0, 1, 2, 3 kilometers, 4, 5, 6 kilometers. And then on our x-axis, the horizontal axis, will be our number of hours. So our time in terms of hours. So let us say this one is 0, 1, 2, 3, 4 hours, 5, 6, 7, 8, 9, 10 hours. So again, the horizontal axis is the x-axis and the vertical axis is the y-axis. So at 0 position, at 0, 0, time 0, position 0, it is at this position. Or it is at this location of the graph. And then after 2 hours, so 2 hours, it is at 1 kilometer. And then on the 4th hour, so it is at 2 kilometer position. On the 6th hour, it is at 3 kilometer position. On the 8th hour, it is at 4 kilometer position. And on the 10th hour, it is at the 5 kilometer position. So this is the graph. It looks like a straight line graph. So every straight line graph, if you could recall in your mathematics, straight line graph is a linear graph, or it is a linear equation. So every straight line graph has a slope. So a slope is the rise over run, or the steepness of that straight line graph. So in terms of mathematics, it is change in y, or the rise over the run. So change in y over change in x, the rise over the run. In our graph, it the rise or the change in y is represented by position. So it will be change in position, and here the x is time, so change in time. If you recall, change in position is just the distance between 2 points, and the change in time is just the time. So distance over time is actually velocity or speed. So therefore, the slope of a straight line graph represents the velocity of the object, or in this case, the student. So the velocity is represented by the slope of the graph. So let us now compute for the velocities. So the velocity is distance over time, or change in position, which is 1 minus 0 over change in time, 2 minus 0. So 1 divided by 2 is 0.5 kilometer per hour. And doing the same with the rest, we have all 0.5 kilometer per hour. So the velocity did not change. So that will tell us that the velocity is constant and it is positive because you don't see any negative value here. So the velocity is constant. So if you can see this kind of graph, that velocity is a constant positive velocity. Now what if we have this data? At 0 hour, the student or the object is at 6 kilometer. After 2 hours, it is still at 6 kilometer. After another 2 hours, still at 6 kilometer. Then another 2 hours, 6 kilometer. Another 2 hours, 6 kilometer. And another 2 hours, 6 kilometers. So what do you expect from this one? So the object is not moving at all. So how does the graph look like? So at 0, at 6 kilometer times 0. At 2 hours, it is at 6 kilometer. At 4 hours, it is at 6 kilometer. At 6 hour, it is at 6 kilometer. At 8 hour, 6 kilometer, and then 10 hour, 6 kilometer. So you would expect that the graph for anything that is not moving is a horizontal graph. So no movement upward and no movement downward, meaning it is not moving at all. So the velocity as computed here is 0. So we can say that the velocity is 0 if we have that kind of graph. So this kind of graph represents a 0 velocity. So what if we have another this data? So you have at 0 hours, the object or the student is already at 5 kilometer position. So it is starting at a 5 kilometer position going towards the 0 position. So after 2 hours, it is at 4 kilometer. So let us graph. At 4 hours, it is already at 3 kilometers. 6th hour, it is at 2 kilometers. 8th hour, 1 kilometer. Then on the 10th hour, it is at 0 kilometer. So you are looking at a going down straight line graph. So let us go through the velocities of this going down straight line graph. So the velocity is a negative 0.5 kilometer. So, and then another negative 0.5 kilometer, and then another 0.5 kilometer. So the velocity is again constant but negative. Okay. So every time you see this kind of graph, then you could say that the object is moving towards the starting point, or the object or the student is going towards the opposite direction. So instead of going away from the starting point, it is going towards the 0 position, or the starting point, or the supposed starting point. So every time you see a graph that is um, declining, so the slope for that graph is negative. And so with the velocity. So the velocity is a constant negative. So to sum the three up, so every time you see a straight line graph going up, that is a constant positive velocity. A 0 velocity if that is horizontally aligned, and declining or going down a straight line graph is a constant negative velocity. Now what if we have two kinds of graph? We have the blue one as less steeper and the green one as a more steeper graph. So since these are all straight line graph, we would expect that the velocity here is constant. So how does the green graph and the blue graph differ? So let us try to have some values. So for the blue graph, we have the position has reached 3 kilometers, example, in 9 hours. So if you divide 3 divided by 9, that will be 0.3 kilometer per hour. So that's the velocity of your blue graph. And then for our green graph, we have 6 kilometers. It has reached 6 kilometers in 5 hours. So we could say that it has a velocity of 1.2. Therefore, the difference between the two is that the green one has a greater velocity compared to the blue graph. Therefore, by looking at the graph, even without computing the values, we can say that the steeper is the slope of the graph, the greater is the velocity. Since slope is represented, or since slope represents the velocity of the graph. So the steepness will tell you which graph has a greater velocity. Okay, now we'll go to the accelerated motion. Accelerated meaning the velocity is either increases or decreases. So what if we have this kind of data at 0, if the position is 0. After 1 second, the object or the person, so do not consider this one as the person. You may consider this one as the person, as the student. So at 1 second, it is already at a 5-meter position. At 2 seconds, it is at a 20-meter position. So I don't think a student can do this. So we'll just have it as a ball rolling, or let us say an object going down under the influence of gravity. And then at 3 seconds, it is already at 45 meters. So let us graph this one. So at 4 seconds at 80 meters and 5 seconds at 125 meters. So let us graph this one. So at 0 seconds, the object is at 0 position, 0 meters. At 1 second, it is at 5 meters. At 2 seconds, it is at 20 meters. At 3 seconds, it is at 45 meters. At 4 seconds, 80 meters. 5 seconds, 125 meters. So if you draw a straight line graph, clearly the graph is not a straight line. It is a curved graph. So let us go through the velocities at each time interval of this data. So at first interval, the velocity is 5 meters per second. Second interval, velocity increases to 15 meters per second. Third interval, the velocity increases to 25 meters per second. Fourth interval, the velocity increases to 35 meters per second. And the last interval, the velocity increases to 45 meters per second. Clearly, this shows us that in a curved graph, the velocity is increasing positively because the values are all positive. So we can say that this kind of graph, a curved graph, will here's another way of, so you can determine whether the velocity is increasing by drawing a tangent line. So a tangent line is a line that touches once on a curved graph. So we draw a tangent line and it touches only once, or one point of the graph. So this is our first tangent line, the red one. So it has a certain velocity. It is not that steep. It has slope but not that steep. And we draw another tangent line which is a much steeper slope. So we can say that it started from a zero velocity to a certain velocity to a greater velocity. So we can say that the velocity increases with time. So therefore, we can conclude that uh, this kind of graph has a positive because the slope is positive, and increasing velocity. If you could see the letter V here, it has a small velocity, then a greater velocity. Again, you look at the slope. This one is less steeper, so less velocity, more steeper, greater velocity. So we can have another curved graph. So let us try to check what happens to the object or to the motion of this graph. So first tangent line, it has a certain velocity, so it looks more steeper. Now let us look at the second graph. Okay, the second tangent line is not that steep. Therefore, we can say that the velocity started from a greater velocity to a lesser velocity. Therefore, velocity is decreasing and the slope of the tangent line is positive. So, decreasing positive velocity. Another tangent line. So, another curved graph. So, draw a tangent line. First tangent line is not that steep. I mean, the slope is not that steep. And the slope is negative because that is going down. Then the second tangent line is a steeper slope. So, greater velocity and still a negative uh, slope. So, therefore, we can say that the velocity started from a less velocity to a greater velocity. So, meaning the velocity is increasing negatively. And the last curve graph is, or let us draw a tangent line. So it is a more steep first tangent line. Then the second tangent line is less steeper. So therefore the velocity is decreasing negatively. So why do we start? So we always start to draw a tangent line nearer to the zero mark. So that is the zero mark is here. So we should start drawing tangent line here rather than on this part right here. So we started here and then proceeds to that part right there. And we started here and proceeds to that part right there. So again, from left to right. So that's why we can conclude that there is a changing velocity from left to right of the graph. So there is either increasing or decreasing velocity in this kind of graph. So we're done with the curved graph. Let's proceed to the graph, the position time graph. We will represent or convert that one into a velocity time graph and acceleration time graph. So using our first example, first data. So the velocities are constant, 0.5 meters per second, constant velocity. So we will put that one in a table. So at same time interval, wait, um, so this is in R. So the datas are, I mean the units are not correct. So this is supposed to be R's, then kilometers. So just think of this as R's and kilometers. So our velocity is 0.5 kilometer per hour. And then we will try to check if there is an acceleration for this one. So we will try to have this first interval. We will skip 0. So first interval, no, the datas are not correct. Okay, let's go back. So I made some changes. Oh, I was not able to make some changes on this one. So the unit should have been kilometer per hour. So again, if we plot that on our graph, it will be yes, it's already in kilometer per hour, 0.5 kilometer per hour, a constant velocity graph. So we will compute for the acceleration if there is. So you have here the values are all 0. So the formula is or comes from this formula: acceleration equals change in velocity over time. So our value, our graph for our acceleration time will be 0. The values of accelerations are all 0. So if we graph that one here in our position versus time, so a straight line graph of position versus time will have a velocity time graph that looks like that one. So a straight line graph, because that is a constant velocity. So it's not 0. So if it is 0, it is supposed to be here, but it's not 0. It's around 0.5. So the value of your velocity is 0.5 constant. Now do not confuse yourselves to consider this one as a 0 velocity, because in our previous position versus time, this is a 0 velocity graph for our previous position versus time. But this is not anymore position versus time. This is velocity versus time, and the value of the velocity is on the left side. And for our acceleration versus time graph, so the values are all 0 in 10 hours. So you would see that kind of graph. So for our straight line graph, position versus time graph, the velocity is a constant velocity, a horizontal velocity, but not 0. And our acceleration is at 0 for the whole duration, meaning to say the object or the student did not accelerate for that whole duration of the travel. So next we have another data, an accelerated, or let us say an increasing velocity data, the one we had before. So again, compute for the velocities. We already know that one. We already have computed, or you already have seen that one. And put that one on a table. So you will have a table of velocity versus time graph that looks like this. So you have seen the velocities are 5. So you have 5 here, 15, you have 15, 25, you have 25, 35, you have 35, and 45, you have 45. So to compute for the acceleration for this one, so the acceleration at 1 to 2 time interval is 10 meters per second squared. And then we have the second time interval is still 10 meters per second squared. And then still 10 meters per second squared. And so our graph should look like, I know, our table should look like this one. So we have a constant acceleration value. So let us try to check the graph for this one. So here is our increasing velocity position versus time graph, a curved graph, and our velocity versus time table, and our velocity versus time graph. So see the difference between a constant velocity motion and an accelerated motion. So you have a straight line graph for velocity versus time compared to a uh, constant velocity motion a while ago. You only have a straight line horizontal graph. And for the acceleration, since it has values of acceleration, so the acceleration value or graph should look like this. So from a curved graph to a sloping graph to a horizontal graph. You follow? So let's proceed to a non-constant motion. So a student walks from school towards home with the following data below. So here are the data. At 0 hour, the student is at 0 kilometers. After 2 hours, the student is at 4 kilometers. After another 2 hours, the student is still at 4 kilometers. And after 2 hours, the student is already at 3 kilometers. So seemingly it is going back niatras kadiyot. And then after 2 hours, it is still there at the 3 kilometer position, meaning to say it is not moving for 2 hours. And after 2 hours, it is at the 5 kilometer position. So let us look at the graph. So again, plot it on an XY plane. In this case, our position versus time graph. So at 2 in 2 hours, it is already at a 4 kilometer position. So this is the 4 kilometer position. Then it stays there for 2 hours, for another 2 hours. So for another 2 hours, it stays there. And then somehow goes back to the starting point. So at 3 or near or almost to the starting point at 3 kilometer position. And then stops there for 2 hours. And then walks away from the starting point for another 2 hours up to the 5 kilometer mark. So let us try to compute for the velocities of the data. So we have the first one is 2 kilometer per hour, not 2 meters per second, but 2 kilometer per hour. Just disregard the unit. And up for the second interval, we have at 0 position, 0 velocity. So again, if whenever you see a horizontal graph for a position versus time graph, the velocity is 0. So if you look at this also, the velocity there, we will expect that the velocity is 0. And for this graph, we will expect that the velocity is negative because that is a going down slope. And for this one, a going up slope, so that is a positive velocity. So let's see. So we have negative 5, and we have 0, and we have 1 kilometer per hour velocity. So again, disregard the unit. So if I'm going to ask you at which time interval is the velocity highest, or is the speed highest? Okay, obviously, the one having the greatest speed is 2 meters per second. Therefore, it is at this time interval from 0 to 2 hours that the velocity is highest. So at that point, the student was walking faster. Now, if I'm going to ask you at what time interval indicates that the student is going back towards the starting point. So the answer is at this graph or at the interval 4 to 6 hours. The student goes back towards the starting point but did not reach the starting point. It only walks around 1 kilometer towards the starting point. At what time interval is the velocity 0? So that is at 2 to 4 hours and 6 to 8 hour time interval. Do you follow? So this is what we call graphical analysis. So in summary, we have discussed how to graph from a table to a position versus time graph. So here's another example. This is not yet a summary. So this is a second example for this kind of graph. So again, this table is represented by this graph. So let us try to determine the velocities. So the velocity is 2 meter per second at that particular time interval, 0 to 5 seconds. Then 5 to 10 seconds, the velocity is 4 meters per second. At 10 to 15 seconds, the velocity is 0. So it stays there for 5 seconds. And then another 5 seconds or 15 to 20 seconds, that is 1, or it has a velocity of 1 meter per second. And the last interval has the biggest velocity, which is 7 meters per second. So that's a 7 meter per second velocity, negative, because the slope is a downward slope. So it is going back to the starting point. So it has walked already around here 35 meters, and then it goes back to the starting point. So it is at this point that the student went back or goes opposite to its uh, previous direction. So if I'm going to ask you which one has the greatest speed, or which time interval has the greatest speed. Again, speed disregarding the negative. If that is velocity, then you'll have to consider the negative. Although the negative would just tell you about the direction. So if I ask which in time interval is the speed the greatest, it is at this time interval. So at that time interval, the student is walking fast. And which time interval is the velocity 0? So obviously on the flat. That's it. Now, if I'm going to ask you a different question in terms of displacement, or yes, this distance first. How far did the student walk? So what is the total distance the student has walked? So if you are going to look at our graph, so it has walked in terms of meters. This is not kilometer. So it has walked 10 meters, 10 meters up to that point. Then it has reached 30 meters up to that point. Then it reaches 35 meters. Okay, 35 meters. So that's 35 meters. So when we say total, napamanis siya nga kwan. So we need to add this one. So 35 plus another 35 for the going back motion. So the total is around 70. Total distance is 70 meters. When we are asked of what is the displacement, so displacement now is considering the positive and the negative. So displacement, we will just put arrows to indicate that that is a vector quantity. So the displacement is, it has gone 35, positive 35 up to this point, up to this time, up to this moment, and then it went back going towards the starting point with a negative 35 displacement. So if you add positive 35 and negative 35, so positive 35 plus negative 35, so the answer is a 0 displacement. So that's an actual example of the difference between distance and displacement. Distance is the total length covered, while displacement is considering the directions of the displacements of each distances, or not distances, we'll use displacement. So the first displacement is from 0 to this one up to this 35 positive, because that is on the positive direction. Then the other one is towards the negative or going back travel or direction. So that is there, positive 35 plus negative 35 is equal to 0. So displacement is 0 and the distance covered is 70 meters. So going back to our first, for this one, so what is the total distance covered? Total distance covered is from 0, we have 4 meters. Then it goes back to another 1 meter. So 4 plus 1. So this one here is 1 kilometer. and here is 4 kilometers. I hope you are following. And here 0 kilometer, and here is a 2 kilometer. So we have 2 kilometer, we have 1 kilometer, and we have 4 kilometers. So all in all, we have 7 kilometer. And our displacement is again considering the positive and negative. Considering the positive and negative, so we have positive 4, then negative 1, because that is going down. So minus 1, it becomes 3, plus 2, so we have 5. So again, I will write it down here. We have positive 4 plus negative 1 plus positive 2 is equal to 5 kilometers. So see the difference between distance and displacement. So let's proceed to the summary. So you were able to graph motion, you were able to determine positive, um, you were able to know that this graph has a constant positive velocity, and this one has a zero velocity, and this one has a constant negative velocity, all straight line graph. And for a curved graph, you're able to graph a curved graph, and you're able to realize that a curved graph is or has a changing velocity. It could be increasing velocity or decreasing velocity. And we also have identified so these three different curve graphs, so we're able to know if that is decreasing or increasing positively or negatively. And then we also have discussed this one as how to convert position versus time graph to acceleration versus time graph. And then this one is a curve graph, and then you were able to see the conversion from position versus time to velocity versus time and to acceleration versus time. And the last one is we discussed about non-constant motion. So you were able to know the velocities at every time interval and also the distances and displacements. So that will be all for today. Goodbye.